Well, happy Thursday. Hope you're doing well. Hope you felt good about yesterday's test. L102. I didn't do the big clap for you guys, and I think it was because I mashed up L99 and 100. But I've done the big clap for everyone who's achieved 100. You are the last to get there, but that's not your fault. We take our time in 5th grade. But, we're at L102. I'm going to do the big clap right now. Man. I love working with your grade. You're the youngest grade I get to work with, and I feel like we get to expose you to such great new ideas in math. And I just want to say I really appreciate all the hard work you've done for me. I know that I ask a lot. I know that my expectations are high. I've always found in my career that that's just the best route. So sorry that you're kind of a part of that, and that maybe it feels victimizing because it's hard and I expect so much. But I hope it'll all pay off for you in spades in the future, and I look forward to hearing about your future. So let's dive into what I love, L102, finding the percent of a number. So let's write down this model question. It says, what number is 75% of 12? Maybe some of you already know this, but we're going to explore kind of things to do here, because what I really want 5th grade to be about is setting you up for your future, foundational future. And your future, friends, is algebra. And so our goal here is quite clear in my mind with a question like this. Our goal is to take this English language and form, can anyone guess? Okay, go ahead. Very good. Our goal is to form equations with a statement like this. We want to be able to take our English language, such as a phrase like what number, or the word is, or what does this word of mean in math? And we want to translate it into math language, into equations. So we're going to focus here on this what number. What number is kind of like a question, right? And if it's a question, that means I don't know it. And in math and in your future of algebra, remember we call it algebra because of the use of variables. And so when we see a phrase like this, a question like this, we want to translate that into a variable. Now, you can use any variable you want. However, when it asks me what number, I usually just use n. And I think it's a pretty good one, n for number. Now, this word is. Now, if it's a mathematical equation, then an equation means that it has the presence of an equal sign. And the word is in math basically means equal. We're going to jump over to this of word real quick. I think we've already discussed this, but about 98% of the time when you see the word of, I want you to think of one operation only, and that operation is multiplication. We're going to drop this 12 over here, and then we're going to consider this 75%. We know that percents can't remain as percents when we throw them into equations, and they take one of two forms. I know you know the forms. One is we should know the fractional form of 75%. Just think of cake. And if you do think of cake, you're probably like, well, I know that's 3/4. And I hope that you do know that. If not, study up over the summer. You're going to need to know it in 6th grade. Decimal form, well, we've talked about moving the decimal point twice to the left and putting a 0. So we should know at this point that 75% is simply 0.75. So what should I plug in? Well, we're going to actually do it both ways. So we're going to start with plugging in this 3/4. And I'll put in that 3/4 for the 75%. Now, when we multiply fractions or a fraction in a whole number, we want to look for cross-canceling opportunities. Hopefully you see it here with this 4 and this 12. Their GCF is 4. Therefore, 4 divided by 4 is 1, and 12 divided by 4 is 3. Then I can simply say, okay, n is equal to 9. Now, this is a little heady, but the n is something that we came up with. So to answer this question, I really wouldn't box up the n at all. I would just box up what number is 75% of 12? 9, yeah? Now, what if we went the decimal route? Would we get a different answer? Oh, dear Lord, no. We wouldn't get a different answer. It would just look a little different. So what would I write? I would write n equals 0.75, or 7500ths, times 12. And this is something that we'd probably need to set up the multiplication algorithm for. Notice how I flushed right. I'm not worrying about decimals right now. I'll focus on the 2. 5 times 2 is 10. Carry the 1. 7 times 2 is 14, plus the 1 is 15. And then tag is 0. 5 times 1, 5. 7 times 1, 7. No need to multiply anymore. So I'll add 0 plus 0 is 0. 5 plus 5 is 10. I'll put the 0 and I'll tag the 1. 1 plus 1, 2 plus 7, 9. Now we consider decimal. And then, so I'm going to tag, boom, boom, and there's my decimal. So I could say n is equal to, just like before, 9. Again, not different answers, just kind of considering it differently. Yeah? Although one of them seemed a little easier. All right, let's look on. Write this down. 60% of the 25 students visited the library. What's the question, though? The question is this: how many went to the library? So again, if we're going to go full on algebraic equation, we want to think about, okay, I've got 60%. Should I go fraction? Should I go decimal? I've got 25 students. And then I've got a variable. How many? So I'll go with m. How many went to the library would be m equals, and then the 60%. So 60% in a decimal form, we should know, is just simply 0 and 6/10, like so. In a fractional form, well, that would be 60 over 100, because a percent means of 100, but reduced is 3/5. And again, given this situation, and considering what I'm going to be multiplying this by, this is a no-brainer for me. I'm definitely going to go with the 3/5. Seems easier. So I'll say, okay, 3/5 times 25. We know that 25 exists over 1. If you want to place that, you can. It's not necessary. Then I'd see the cross-canceling opportunities between the 5 and the 25. So GCF is 5. So this slashes out to be 1. And 25 divided by 5 is 5. And then simply m is equal to 15. Now, I can't box this up because this is a word problem, and it wants to know how many students went to the library. So I could say 15 students went. And that should be clear enough, and box that up. So again, I'm always given a choice. Should I go fraction? Should I go decimal? And one way isn't more right than the other. It's just, in this case, it seemed more efficient to go with the fraction, and that's why I did so. Efficiency is key. Let's look at this. Write it down. What is the amount paid in tax for a $15 shoe if the tax rate is 6%? So imagine you lost a shoe, and you still got the other shoe. So it's not a pair anymore, but you love these shoes. So you're interested in just buying the other, let's say the right foot shoe. So it's $15, but we do have to pay tax. So tax on a $15 shoe, and our tax rate being 6%, basically the way that tax works is that I'm going to have to pay something to the government for purchasing my one and only shoe. So what can I do? Well, I'm going to take this $15, and I have to change that 6%. I can change it to a fraction. This time, though, let's change our 6% into a decimal. So we know that would be 0.06, because I'm going to move that decimal twice to the left. We've gone over those ideas before. So when I multiplied 0.06, notice I flushed right, not worried about decimals right now. I do 5 times 6 is 30, so I carry the 3. 1 times 6 is 9. We know the rest would be zeros, so now I'm just going to focus on, I've got 2 digits to the right of a decimal place in my factors, and I go boop, boop, and that's where my decimal would be. And again, this is on, we know that there'd be 90 cents in tax. Now, if they're asking us a different question, such as, what's the total cost? This is just my tax, right? So if they asked me what the total cost was, then I would have to take the original shoe price at $15. I'm going to tag some zeros there and put a decimal place. And I would add my 90 cents in tax, and I would get $15.90. But they actually didn't ask me that. They just want to know what is the amount paid in tax. So that's that answer, 90 cents in tax. And because that's what they asked, this is what I would box up. And be like, well, why did we do the other one? Well, because sometimes they're going to ask you the total cost. And you got to be the thinker. So if they do ask you for the total cost, one way to do it is find the tax and then add it to the original price. All right. So I'd say uno mas, but this is actually 3 more questions. Go ahead and write down what you see, including the little chart. Here they're interested in something called discount for the items below. In the first situation, a $10 belt, a discount of 15%. Next one, a $50 jacket, 20% off. I'm sure you've seen something like that. Next one, a $100 coat, 30% sale. And strangely, even though we use words like discount or 20% off, or a 30% sale, they're all actually meaning the same thing. So we've got 3 problems. Let's do it. $10 belt, discount of 15%. Let's go $10. We'll multiply it by the decimal form of 15%. And so here I could actually tag this 0 right now. And then I'm going to focus on 1 times 5 is 5. And 1 times 1. And then I'll consider decimal placement. Boop, 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 boop. And so I would say that I will pay for this one a discount. Not what will I pay. I have a discount of $1.50 off of my $10 belt. If they're asking me what I will pay, that in discount, what I'd have to do is subtract it. But I'm not, because they just want to know what the discount is. I should box that up, but I'll box it up in just a moment. Let's do my $50 jacket at 20% off. This time, instead of percent, instead of decimal, I'm going to go fractional. So 20%, I should know at this point, is simply 1/5, right? And so, think of cake. So if I take my $50 and I multiply it by 1/5, that'll tell me how much off, like how much the discount will be. So I see a nice cross-canceling opportunity here, and then I could just state out that it will be $10 off. And that's what we call our discount. How much would the jacket be? Well, I would subtract. I'd say, well, it's going to be a $40 jacket. So that's an answer, boxed. Here's the other answer, boxed. Last one, $100 coat. $100. Ooh, that must be a nice coat. So 30% sale. So, of course, what would I do? I would take my $100. It looks like I got a choice here. Should I take the 30% and go fractional? Or should I go decimal? And this is going to be something that, guess what? You get to choose. I'm going to let you choose, but then you're going to post. So you're going to choose, and you're going to tell me in Google Classroom, did you go fractional or did you go decimal? And then what was your answer? What was the discount on that $100 coat? Obviously, our answers should be the same, but maybe some of us will go fractional, 30%. What is that in a fraction? Some of us will go decimal. What is that as a decimal? And then do your math, do your multiplication, and then once you get your answer, just type into Google Classroom, fraction, answer, or decimal, and then answer, yeah? And that'll be fun. I can't wait to look at that. And once again, because I didn't do it before, I'm slow clapping you guys again. Well done. Thank you, 5th grade. Thank you for all the hard work. I do believe in the end it credits you and benefits you. That's why we do it. L102, finding the percent of a number. I am listening to my sister-in-law who decided to start singing. Hopefully you heard it. She has a lovely voice. You are expected to do the homework, HW102. Bye.